This question is a bit straightforward. There are four forces acting on this balloon, and the vertical forces are acting in opposition, and the horizontal forces are acting in opposition. So you can think of it like basically a tug of war in 2 dimensions. So the best way to approach this question is to assign a positive and a negative to the vertical, and a positive and a negative to the horizontal. And then we're just going to find the net force. So then, I mean, basically what we're doing is the vertical becomes the y, and the horizontal is the x. And we're going to think about this in terms of finding the net force along the x direction. And that's simply going to be the forces along the x direction. So 950 newtons minus 1520 newtons. And you get a number there, which is, you get negative 570. And we can do the same thing for the y. F net along the y is equal to, let's see, 5120 newtons minus 4050 newtons. And doing that math, we get 1070 newtons. So what we found is the x and the y component of the net force. So you can think of it like this. We've got the x component, which is in this direction, is negative 570 newtons. And the y component, which is positive, well, let's just do this. Instead of calling it negative, I'm just going to write down the magnitude, 570. It makes the math a little easier, and I'm just going to internalize the fact that this arrow is pointing to the left, so I know it's a negative. When I put in the positive, it'll be here. And remember, I'm adding these tip to tail. That's how I know they're in this direction. This is 1070 newtons. And then the resultant, or the net force, is going to be a vector addition of those two. So this is my F net. And this is my F net in the x and my F net in the y. So there's 2 parts to this. We need to know what F net, the length of that red arrow is. We also need to know the direction it's pointing. All right, so let's do that math. We're going to use Pythagoras to find, so we can use Pythagoras to find the length, which, so we would just say F net is equal to the square root of 1070 squared plus 570. See, you see why I didn't put in the negative, because it's going to give me the magnitude of the net force, which is all I really need. So let's see, putting this into the calculator, I will, oops, I don't know if I did that right, yeah. 1070 squared plus 570 squared, and then I'll take the square root of that, and I get 1212, as the answer says, 1212 newtons, and that's the magnitude. So now we need to figure out what direction is this thing going, and it's not north, south, east, west. It's kind of like a up, down, left, right. So it's a little tricky to figure out how to report this, but you have the theta there, and I know the opposite. So if you see it, think about it, this side is the opposite to that black theta, and this is the adjacent. So when I solve this, I can do opposite over adjacent, which is just the tan. So oops, what I can say is tan theta equals opposite over adjacent. So I don't know what theta is, but tangent of theta equals, now the opposite is 1070, and the adjacent is 570. Did I get that right? 1070 and 570. Okay, so to solve this, I'm going to do tan inverse. So theta equals tan inverse of this division, 1070 over 570. So when I find theta, I get 1070 divided by 570, and I'm going to tan inverse my answer. I get an angle of 62 degrees, 61.955. So I'm going to call that 62 degrees. So how do we put this all together? So what this, we can see this angle is, the way the answer was given, it says above the 1520 Newton force. I mean, that's one way to put it. You could say the answer is F net is 12 newtons, and you could say left 62 degrees up. I mean, you could have put it, I mean, there's a lot of ways you could have put it, but as long as it makes sense and you've communicated it in your answer, I would accept it. So you could have put up from left, you could have put, you could have used the complementary angle and said down from, or left from up. I don't know. There's a lot of different ways you could have put it. Okay?